A large number of people arrange themselves into groups of 2, 5, or 11 people. The mean size of a group is 4. So let's say that there are X groups of 2, Y groups of 5, and Z groups of 11. If we had, say, 3 groups of 2, then there would be 6 people overall in those groups. So if there's X groups of 2, then there's going to be 2X people in those groups. And for Y groups of 5 people, there's going to be 5Y people, and then 11Z people in the Z groups of 11. Now we're told that the mean size of a group is 4, so we've got the total number of people, and I need to divide by the total number of groups, which is X plus Y plus Z, and that is equal to 4. I've created an equation. Let's multiply through by X plus Y plus Z to give 2X plus 5Y plus 11Z is equal, and I'm going to go ahead and expand the bracket while I'm at it, 4X plus 4Y plus 4Z minus 4Y and 4Z from both sides, which gives me Y plus 7Z minus 2X from both sides. Y plus 7Z is 2X. And I've got it as simple as I can for the time being. That is a relationship that must be true. Next up, each person is asked how many other people are in their group, excluding themselves. So let's say we asked somebody in a group of 2, they would give an answer of 1. Therefore, when the 2X people in the groups of 2 are asked, they're all going to say 1. And I'm going to keep track of the total uh, sum of all of their answers. So in the groups of 5, we've got Y people, so 5 Y people are being asked, and they're each going to say 4. And then in the 11Z people in the Z groups of 11, they're all going to reply 10. So I will do 11Z times 10 to add up the numbers that they all said. They said 10, 11Z times. This is probably the hardest bit to get your head around in this question. And then we need to divide, so the mean answers, we need to divide by the total number of people now, which actually takes us back to that 2X plus 5Y plus 11Z, not the total number of groups, the total number of people. And that is equal to 6. And we've got ourselves another equation. So you could multiply, but there's a nice little thing that you can notice, and that is the numerator has a common factor of 2. So if I divide left and right by 2, I can cancel that out, make that a 2, make that a 5, and make that a 3. I've just divided through by 2. I need to divide the numerator and the right-hand side. This means that x plus 10y plus 55z, let's keep it as a fraction for the moment, 2x plus 5y plus 11z is going to equal 3. Right, now I'll multiply across. So x plus 10y plus 55z is equal to 6x plus 15y plus 33z. Okay, and again, I'm going to simplify it. So 22z is going to equal 5x plus 5y. I've kept them all as positive. That is another equation that relates x, y, and z. Now let's just remember what we're trying to do. We're trying to show that the number of groups must be a multiple of 27. I don't think we're going to be able to work out x, y, or z here. We've got 2 equations with 3 unknowns, but we want to investigate the total number of people. So essentially x plus y plus z. That's what we want to show is a multiple of 27. Okay, well let's link them together. For this one, I can make y the subject. It makes sense to use y because it doesn't have a number to its left. Its coefficient is 1, and therefore it's going to be the easiest to sub in here. Otherwise, we're going to get fractions. So y is equal to 2x minus 7z. And that means that 22z equals 5x plus 5 times 2x minus 7z. And I can relate x and z together. So 22z is 5x plus 10x minus 35z. And therefore 57z z is equal to, sorry, I think I made a mistake. That should have been an x. Put it in time though, so 57z is equal to 15x. These are both divisible by 3, so 19z is equal to 5x. And what that means is x is equal to 19 fifths of z. Okay, so I've related to do the two together, which is what I'm after essentially. Let's do the same with y. So y, remember, is equal to 2x minus 7z. So I can now replace x by 19 over 5z. So y is going to equal 38 over 5z minus, we can put this over a common denominator of 5, 35 over 5z. That gives me 7z, which is going to give me 3/5 z. Okay, so I've got x in terms of z, and I've got y in terms of z. So what I did at this point is write them as a ratio. X to y to z is going to be 19/5 z to 3/5 z. Oh, sorry, didn't mean that. Just replacing x and y by their respective relationships we just found to z. Multiply through by 5, so 19z to 3z to 5z. And so the sum is going to equal 27z. And therefore, the number of groups must be a multiple, well, it must be a multiple of 27z, but actually it just must, we can just say it must be a multiple of 27. Z must be a whole number, and the result follows. Okay, nice. There's a similar question in the Cayley paper that is a little bit nicer. So if you did struggle with this one, I'd say give that one a go. It's going to be a very similar setup. I'd say actually in either case, try that one as well because it's quite a unique question. And although we can never find x, y, and z, we can determine this nice result.